So welcome to Falling Off the Edge, Practical Uses for Edge Computing. This has been quite an interesting talk to write, because when I started writing it, it was lots of fun, and I was messing around with JavaScript, which I love quite a lot. And then it kind of felt like a whole bunch of companies sort of conspired together to make my life difficult, and I've had to rewrite this like 5 or 6 times in the weeks leading up, because people keep releasing new stuff. I mean, they don't know who I am, so I'm sure it's not a conspiracy, but it sure felt like it. And then people kept arguing on Twitter about what certain words mean and what this definition is and what that is. So we're going to dive into that a little bit. Not the Twitter arguments, but what the words actually mean. So just take some of the things I say with a pinch of salt, because they're kind of open to interpretation, because they don't have like a firm definition. But hopefully you'll walk away learning the history of edge computing, how it started, where we are now, what you can use it for, and some of the pitfalls to watch out for. Because there are a few, especially around distributed data. So my name's Alexander Karan. I've been a software engineer for about 12-ish years, way too long. I'm passionate about privacy and data and the environment, so if you want to come and talk to me about that, feel free. I currently work at Atlassian on the Cloud FinOps team. That's where I will be starting my brand new job next month, so that's going to be fun. So yeah, let's start with what is actually edge computing. So it's really important to understand that edge computing doesn't refer to a particular technology or stack. So a lot of people sort of compare it with JavaScript and certain frameworks. That's not the case. It's actually an approach to architecture with a focus on location and where you place things in the network. So if I was to simplify that, it's running code as close as possible to the end user. Although I may have simplified that too much now. So if you were to put it into context with sort of the tools that you've been seeing in the last year or two, it's running code as close as possible to the end user, but it's globally distributed as well. And you've probably seen things like this. So this is Versal and SvelteKit working together to render a web page using an edge function. If you don't know what that is, don't worry, we'll dive into it in a minute. And we're doing some fancy stuff here using edge middleware to sort of render the IP address and the location. So I'm from Australia, Perth, which is on the west coast, so that's why my city is Perth, not Perth, Scotland, the sunny one in Australia. So where did edge computing start? Well, to actually understand that, we need to go all the way back to the beginning of the internet. So I'm talking about the original internet that connected 4 universities in Northern America, called ARPANET. I think I'm pronouncing that acronym right, maybe not. It's on my blog if you'd like to check out the full spelling and terminology. So we need to look at the original OG server, the IBM 36091. So that is a beast of a server. So many buttons, really want to press them. Anyway, an RFC, so request for comments, was released by the networking working group about how a user on the ARPANET could use production compute services using the IBM 360. Now, servers have changed a lot since then. The hardware's changed, the software's changed, but the basic protocols and sort of format and standards of how a server should work still are the same today as they were then. So as the internet grew, we started to hit issues in the 90s, and this is where CDNs were created. So CDN, or Content Delivery Network, is a way to serve static content to users across the world and sort of cache it close to the user. So things like HTML, CSS, images, files, you name it. So dynamic content would still be fetched from the origin server, but static content would be cached on the CDN servers close to the end user. Now, this is actually the start of where edge computing comes into play, because like I said, it's an architecture, not a particular technology. But these services, or CDN networks, actually evolved in the early 2000s to create what could be considered the first edge computing services. A really good example of this is the file system that was released in Windows 2000, and this allowed a user to access a file that seemed to be on one server would actually be spread out amongst many to reduce the load. Another really good example is Amazon CloudFront, I believe, was released in 2006, 2008. Always get those dates kind of mixed around. And that allowed people to serve static content on a CDN, but also dynamic content as well. So one of the first CDNs to actually serve dynamic content. So I'm going to go on just a slight tangent here for like 2-3 slides, so just bear with me. And the reason for this is I really want to hit home that edge computing is an approach to architecture, not a particular technology. So we all walk around with a smartphone in our pocket, right? More computing power than most base laptops. And the iPhone is a really great example of edge computing here. So Apple does a lot of their encryption and biometrics on the phone, right? Saving their main servers having to do all this work. Now they maintain and update this code. They choose to, for example, to encrypt the photos before they upload them to the server. I mean, for security reasons too, but lots of reasons. So you can argue here this is a form of edge computing because for Apple, the phone is the start of their network and they're choosing to run this code closer to the user for a whole host of reasons, but one of them being speed. And it doesn't have to stop there. We can look at IoT or Internet of Things. That's a word that kind of loses all meaning the more time you say it. But we have things like smart speakers, temperature sensors, door locks, cameras, all this sort of stuff. And the thing is, they're getting smarter, right? They don't just process data and upload it anymore. Some of them are running ML models on them, things like that. And we can argue that this is also a form of edge computing. Now, you can also argue that I'm wrong, right? And those last 2 slides are complete nonsense. But like I said, it's architecture, and I want you to keep that in mind. Because now we're going to dive into the new stuff. So edge functions. So you've probably all seen over the last, I think it's what, like 2 years? Lots of sort of cloud providers have been releasing their new edge production services. And they mention edge functions a lot. A really good example is Netlify Edge. I think this is kind of the best messaging without muddying the waters too much. So Netlify Edge is an advanced global platform for powering web experiences that are fast, reliable, and secure. Make your websites feel nearly instant for every visitor. Another really great example is Cloudflare Workers. Deploy your code globally at scale. Now, what are edge functions? What are they? What does it mean? What's a function? Well, to understand edge functions, we have to understand serverless functions, right? So with a traditional server, you pay for every minute that it's running, right? You might provision something on EC2, install your software, whatever you're running, and you pay for every minute that server is running. Serverless functions, you write the code, upload it to your cloud provider, and you only pay for the seconds or minutes that it runs. Once it shuts down, that's it, you stop paying. A really good example of this is AWS Lambda. And you might write an edge function for an endpoint on an API. And when you call that endpoint, the function spins up, does some code, responds, and then shuts back down again. Okay? So an edge function is like where serverless functions and a CDN sort of form together to create this brand new thing, right? So an edge function is still serverless functions, but we're distributing them across an edge network, running them close to a user. For example, I might spin up a serverless AWS Lambda in Sydney, which is the nearest data center to where I am. But the thing is, if someone accesses it from America, they've still got to come all the way to Sydney. But with edge functions, they're distributed to servers across multiple countries. So you're routed to the closest server to you, giving you a faster response time. Now, one of the sort of pluses of an edge function versus a serverless function is something to do with cold starts. So when a serverless function starts up, it has to provision all the software that goes along with it. And when this happens for the first time, this causes a slight delay in response, right? So it's not just, here's your request, there's your response. It's here's the request, create the function, then do the response. Now, once it's, responded for the first time, it gets cached and it sticks around, right? So we don't get that cold start until your traffic spikes and we have to spin up another instance of the function. But edge functions tend not to have this issue. They tend to have something called instant compute and get this really fast response time. And we'll dig into why in a minute. It's a little interesting, and that's where some of the arguments come in. So frameworks like SvelteKit and Deno and Fresh and Next.js are taking advantage of these edge functions, which remember are serverless functions but across a network, to render their web applications. So let's look at Edge Runtime, and this is the murky waters, right? So this is what everyone argues about, because there's no such thing really as an edge runtime, but there sort of is, but there sort of isn't, and everyone can't agree on it. So my best sort of explanation to you is that edge runtime is more about the cloud provider that you're using to distribute your code or functions or whatever that run across an edge network. And it's more about checking what they use and what their limitations are, rather than sort of defining a global term for edge runtime. Sometimes another way people think about it is edge runtimes are mostly JavaScript, because JavaScript's great. Obviously, it's not great everything, but a lot of edge runtimes do run JavaScript. But it's more of a lightweight runtime, so think more of the browser rather than Node.js. But let's have a look here. So we've got AWS Lambda. Okay, so if you use a traditional regional setup, it uses Node.js. Now you can actually optimize Lambdas to run in edge locations, but that also uses Node.js. Cloudflare workers use a V8 isolate for both regional and edge, and Deno deploy. So Deno is a new runtime for JavaScript created by the creator of Node.js. And that uses their Deno for edge runtime. Now, it's really important here, so we'll sort of dig into Cloudflare workers to give you an example of why the runtimes are different and you get this instant compute, right? So traditional serverless providers use a containerized or virtual machine to run an instance of a language runtime, where Cloudflare workers, on the other hand, they pay the overhead of JavaScript once at the start of a container. And this allows them to essentially run limitless scripts with little to no overhead by creating a V8 isolate for each Cloudflare worker or function call. And this means that they can start over 100 times faster than Node.js running on a container or virtual machine. And it also means they consume less memory. So this is one of the reasons with Cloudflare workers, for example, that you don't tend to get those cold starts. I say tend because, as programmers, we can write bad code that, creates cold starts, I'm sure. There's always exceptions to the rule. But that's one of the reasons why you get this instant compute. Now, it may seem that I'm bashing serverless a little bit here, and I'm like, hey, let's all just use edge functions because of cold starts. But of course, cold starts can be optimized. We can think about the way we architect our serverless functions, and we can improve them. And then the final place that you might have heard of the edge runtime is from Versal, because Versal were like, hey, let's confuse everybody and have an open source project called Edge Runtime. So their project is allowing you to sort of use compute locally on your computer that simulates the edge, and is also about creating a compatibility layer for JavaScript APIs. And for them, and this is where it gets confusing, so I'm confused and I wrote the talk, edge actually refers to this sort of process of instant compute rather than a location. That's why it's confusing. And it's part of the Winter CG group, and the sort of goal of this group is to create a unified API layer in JavaScript so you can access the same APIs if you're running in the browser, the server, some form of edge runtime, or embedded devices. And yeah, that's where you might have heard edge runtime. Okay, so we've kind of got like the history of edge computing out the way, some key terminology and what it all means. Before we dig into practical uses, let's just look at why we might actually need edge computing. So the world's data is set to grow to 175 zettabytes? Once again, not sure on the pronunciation there, but I heard someone yesterday called Deno, so I don't know what the correct pronunciation is for anything anymore. So 1 zettabyte is 1 billion terabytes, right? So I don't want to do the whole like data-geddon doomerism thing that some people do. But like if our data continues to grow like this, there is a chance that cloud providers won't be able to keep up acceptable data transfer rates. Now, of course, network technology is always improving. And that statement that I said might be wrong because maybe next year we'll have even faster internet or faster cables or faster servers, whatever. But one of the solutions to this problem is to actually distribute some of our data and programs, right? Rather than just housing it all in 1 or 2 locations. By distributing it across the network, we can reduce that load and keep transfer rates at an acceptable level. So that's where edge computing comes in. Now, to give you an idea of why it works, let's just do this little test I'm not going to do it live. I did it before I came to Oslo. I'm not going to do any live coding. That always goes wrong. So here's a little AWS Lambda that I wrote in Node.js. It's returning a half-baked JSON API response. And then I've got the same code again in JavaScript, but deployed on Deno deploy. So the AWS Lambda was deployed in Sydney, because that's the nearest location to my hometown, where the JavaScript code on Deno deploy was deployed all across the world instantly using their edge network. So I actually pinged this from my hometown in Perth. For those of you who haven't been to Australia, Perth is on the west coast. It's actually the most isolated city in the world. So when I pinged it from Perth, the response times were the same, because the nearest edge location to me is just as far away as AWS. So I turned on a VPN, and I pinged it from Germany, right? So of course, has to go all the way to Germany and then Sydney and back and so on with the VPN. But with the edge function, it hits the nearest edge location in Germany and then comes straight back. So you can sort of see the advantages of using edge functions over traditional serverless functions is because if you've got distributed users that are all over the world, they're all going to get these fast response times. And once again, I pinged it from the US so you can get a similar sort of feel. Okay, cool. So we've got rough example, we've got some knowledge. Let's dig into what we can actually use this stuff for. And there's a whole host of things we can use it for, and a whole host of pitfalls as well. So not everything needs to be on the edge, of course. I'm not one of those crazy people that make YouTube videos, and it's like, I'm moving everything to edge functions, and it's the future. Serverless can die in a bin. No. There's a lot of stuff that does benefit, and full stack frameworks are the best example of this. So I'm going to focus on Netlify and Versal and SvelteKit and Next.js because, if you're not using SvelteKit on Next.js, you're doing web development wrong. That's not true either. It's just I use those the most. But this works with Nuxt. I don't know if it works with Remix. I'm not too sure. There's too many web frameworks now for me to keep track of. But anyway, so traditionally, if you're using SvelteKit on Next.js and you upload it to Versal, for example, it will use serverless functions to render the pages, right? So SvelteKit uses a JavaScript function to render each page. Now we can move that to an edge function, and that way the page is rendered as close as possible to the end user so they get a faster response time. And a really great example of this is what I showed you earlier, is this page here. So this page is actually being rendered using an edge function. And it's actually using something called edge middleware, which is something that Versal and a few other cloud providers use. So middleware in a web application is a function that gets executed before the website responds, right? So what we're doing here is we're intercepting the request with edge functions, we're getting my location and IP address, and then we're using that to change the way the page renders. So wherever you access this page across the world, you're going to get a different rendered page, but you're not going to pay an extra response time because it's got to go all the way somewhere else. It's going to render really close to you. And a really good sort of practical use for this would be a sign-up page, right? So let's say I make a web application. It's only available in Australia, right? So if you access it outside Australia, I can use edge functions to change the way the page looks, create maybe a register your interest form. Maybe I have a list of countries I know I'm going to be releasing to later this year. I can create an edge config, store that list in there, and then we can get a notified page instead of a register your interest page. Now, you might be thinking, well, I could do that anyway before edge functions. What does it matter? And you're right, but the thing is, what I'm talking about here is speed, right? Your users are going to get a faster response time, and this sort of dynamic web page that you've created will render fast all over the world rather than just, where your servers are. So another great example of where these edge functions work is A/B testing. So, every time you build a website or web app, you've got to A/B test a feature or a page, right? Well, normally that requires lots of client-side code, multiple trips to the server, making a request, seeing which version to use, whatever. Well, with edge functions, we can cache each version of a page or feature across the edge network, and then just have one simple call to choose which one gets shown to the end user. Once again, creating really fast response times for dynamic content, right? Not just static content, dynamic content being rendered really fast. Another great example here is the maintenance page. We've all released a feature or something new, or traffic spiked and things crash, well, we can render an edge config that has like a maintenance flag in it, turn it on, and we get a maintenance page instead of the web application. And I'm going to borrow a key phrase from Versal here for two reasons. One, to kind of poke holes in it, and two, sort of, it does explain what they're trying to say. And what they say is, give your users dynamic at the speed of static, which doesn't make too much sense, because just because something's static doesn't mean that it's going to be fast. But the idea here is we can create these dynamic web pages and features and functions and all this stuff that renders really quickly for everyone all over the world. I'm sure we've all accessed websites from another country only to find it takes 5, 6, 7 seconds to load instead of that millisecond response we're used to. Well, now you can create dynamic content that doesn't suffer from those long page loads. Now, it may seem like I'm pumping up Versal quite a bit. I do use them quite a lot. Sometimes it is overkill, but they do have a lot of great stuff. However, you can use all of this stuff in other providers like Netlify. AWS offers a lot of these features too. Not too sure about Azure and Google, because I don't use them as much, but I'm pretty sure, because they all can do the same things. Okay, so we've got a basic web application. You now know that we can render dynamic content quickly and do crazy stuff with it with edge configs as well. But what happens if we need to save state, right? Like, edge functions are great when we're not saving state, but what about state? For any of those of you who deal with databases, I'm sure that voice in the back of your head is creeping up going, distributed data, that's a really scary thing, so many problems. And you're right, but we can actually do quite a lot, right? So before we dig a little bit into the data, let's actually look at Versal edge functions. So each edge function provider has different limitations and different requirements. So it's really important to look at what's available. Even Versal's limitations may have changed literally by the time I finish this talk. Every week new stuff is coming out, and it's made this talk quite stressful. But let's look at Versal edge functions, right? Code size limit is 1 to 4 megabytes, a maximum memory usage of 128 megabytes, and your initial response must be within 30 seconds. Now, I'm sure some of you are thinking, well, how do you install the database driver if you've got such a small code limit? How do we interact with the database when we've got all these limitations? And you're right, we do need to be careful there. Another thing to remember is, because it's a light JavaScript runtime, right, we don't have access to all the same core node libraries that we normally do in a traditional node server. And also, we don't get to use all those wonderful NPM modules. Now, it is worth mentioning that both Deno, Cloudflare, Versal, and others are working at making more of the node APIs available across all of these edge runtimes, but they're not all there yet. So let's have a look at how we set this up, right? With traditional setup, the server spins up, we create a connection pool, and that connection pool is used to make requests to the database. Of course, I'm simplifying that a lot, but connection pools and databases worth their own talk. A serverless setup works a little bit differently. We create a connection to the database, we cache that connection, and then we use that cached connection to make requests. And this can lead to increased cold start times, right? Because the thing is, when you cache a connection for the first time and the function sticks around, once it disappears and we have to, we get that cold start of provisioning the function again for the first time, we then have to create the connection to the database all over again, which increases that cold start. But with Edge setup, we interact with the database using HTTP requests. Nice and simple. So I'm going to start with MongoDB, use them quite a bit, even though they're not web scale. So MongoDB has lots of different drivers for interacting with their database. They have a wonderful tool called MongoDB Atlas, which allows you to, have a traditional, fully managed database that's always running, or even a serverless setup. But they also have a wonderful HTTP library where you can read, write, update, delete data, all from edge functions. So there's a NoSQL option. Or for those of you who like SQL, we have Planet Scale, who have been dropping serverless MySQL. Now, they've actually taken things a lot further, right? And they've built a special fetch-based promise library for interacting with the database from both serverless and edge functions. And this is quite special. And if you want to sort of understand how it works in detail, go read their blogs about it, because it's quite complex. But I'll summarize it in the best way I can, right? So if you connect to their database from an edge function, you connect to the nearest edge location for planet scale. And then it sort of uses long-held connection pools across their internal network to reach the, wherever the data is stored. And we can use this fetch library to create, read, update, and delete. And the nice thing about this is using caching on the edge and their library, we can achieve really fast reads and writes, even from edge locations, using planet scale. Now, there is some pitfalls to this, and you really need to be really, really aware of this. Because you've got your compute or servers, whatever, distributed across an edge network, and the data may only be in one location, if people are reading and writing from multiple places all over the world, you're going to sometimes end up with stale reads, right? People are going to read data that hasn't finished writing or that's being written, and the data they get is out of date. Another thing to watch out for is that a client and a server's relationship is a lot simpler than a server and a database. And what do I mean by this? So, for example, if I have a simple web application that renders all the users in my account, to get all those users, that's normally one request from the client to the server, right? But between the server and the database, it might be multiple. Maybe the first request is checking that this user still exists in the database, has the correct permissions, blah, 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 right? Then the second request to the database from the server is to actually fetch all the users, right? So if your compute is globally distributed, but your database is in one location, so let's say my database is in Sydney, and we're here in Norway, and I make a request, I hit the nearest edge server in Norway, it has to go back and forth to Sydney several times to get all the data. If I just located my compute next to the database in Sydney, it would have been much faster, right? So you need to watch out for this stuff. But I'm not the only one thinking that, right? So like Vercel and Next.js think about this too, and they actually allow you to configure which type of compute you use per route. So maybe for certain routes you use edge functions, certain routes you use, normal serverless functions, so you can locate them next to your data. Another really great example is they actually have this weird setting where they call it regional edge, which, if it's regional, is it edge? Where they're like, it combines the best of both worlds, right? Where you get to use a bit of edge compute with serverless compute and try and locate it close to your data. Okay, so like I said, it's not like this one size fits all, but that's something really to watch out for. But providers are aware of it. Now, just as I was finishing this talk, Deno released Deno KV, a key value database, which is built on top of Foundation DB. So that's used by iCloud and Snowflake, so you know it's been battle tested. And this thing is pretty cool, right? So it allows you to read and write data, delete data, whatever, from edge functions all over the world, and it allows you to store any JavaScript value. And the thing that makes it really interesting is they understand about those stale reads that I was talking about, so they allow you to choose consistency levels when doing a read on the database. So when I choose a low consistency, I'm going to get a super fast read, but there's a small chance the data might be stale. But if I choose a high consistency level, I'm guaranteed the freshest data, but the read will be a little slower, right? And this is huge. Unfortunately, it's still in beta, so you have to join the wait list. But they've put a lot of thought into this distributed data model. Now, of course, this isn't going to be perfect for everything, but things like real-time data from using an application together with multiple users, that'll be great in this sort of thing. Authentication, user data, all this stuff would work really well in here. And they're not the only one. Vercel also released a new Edge config, their own key value database, serverless Postgres, and also Blob. Now, these are built on top of Upstash and Neon, and their Blob is using Cloudflare R2, which I'm a little confused about, because why not just use Cloudflare and it'd be cheaper? But I'm sure there'll be some developer experience improvements on top of it that make it worth it. Maybe you can move faster. But there's a lot of people starting to think about these sort of distributed data models. So what if I need more, right? Like, we've got a full stack web application now. It's got an API. It's got databases, whether they're in one location or globally distributed. It's great. Everything's happy and dandy, right? But what if I now got a mobile app? Or like at my previous job at Climate Clever, we had a web application, but like so many of our users just used our API directly, right? So you need to separate your API from your web application. It needs to become its own thing. Or maybe your team gets bigger, and now you need them to be separated for management reasons, right? So one thing to actually point out here is subscription cost, right? So in this sort of serverless edge world, a lot of the time you need to, just spin up something or do something that would be like a 2-second job if you had a traditional server. But because we're using serverless, we have to reach for another subscription, and before you know it, you're up to your eyeballs in monthly costs. Now, normally this is offset by, the lower cost of serverless, or, maybe not. Actually, maybe it's not offset. Maybe you get your architecture on the first time you do this, and the costs are really crazy. But something to bear in mind. So maybe we need a cron job. Now, normally you couldn't do this with serverless things, but Cloudflare now has something called cron triggers, where you can create cron jobs that run all over the world, easy peasy. Maybe you need to start responding to webhooks or other background jobs or events. We can use new tools like ingest to respond to these from any location in the world, which means we can, still pull off a lot in this sort of edge compute serverless world. Now, obviously, this means a lot of your applications are going to be distributed. You might class a lot of this as microservices as well, and those also have their pitfalls. I'm definitely not one of those people that's like, everything should be one way. There is no silver bullet, right? It's always trade-offs. Nothing's perfect. But, what if we need more, right? What if we're just building an API? What if we don't care about web applications? We don't care about UI. I mean, I spend most of my time doing back-end, right? So try to avoid CSS as much as possible. But, what if we need to build an API? Well, a really great example of this is Deno, right? So we can use Deno and Deno deploy to build an API similar to Node.js and Express, Ruby on Rails, Python, any sort of API framework that you're used to. We can build something really quick and fast and distribute it across an edge network using Deno deploy. And we can use things like Firebase or Supabase for our database. We can use Planet Scale. We can use Deno's new key value store. And we really kind of have to give Deno a lot of credit here, because it's super easy to build something and distribute it. I'm talking seconds. And also, it's really easy to use TypeScript as well. Like, normally with Node, it's super difficult. You've got to have the config and the compiler, and then if Docker's involved, it's like a whole bunch of extra steps. With Deno, it's just super easy. And it's actually worth just sidestepping for a little bit here and just talking about how great Deno is. I mean, personally, if we chose sort of frameworks and tools on cuteness of logo alone, I mean, here, look, there's a little sort of dinosaur riding a spaceship plane thing, or their little shop where they have like Deno Simpson or Deno reading the news or Pride Deno or Space Deno. Like, yeah, if anybody works for Deno, you can tell I'd love some merch. Anyway, so what if, we can't do that? What if like building stuff on new tools like Deno is too risky, or maybe our data has to be in one location, or a previous client I worked for way back where every time we got a new user, we had to spin up a new instance of our backend and database just for them because of security? What about laws and other legal requirements that mean your data can't go offshore, or compute has to be located in certain places, right? Because as much as, JavaScript devs love talking about how all these tools are great on Twitter, the reality is most of us don't use JavaScript, right? Like, lots of big companies are bound by laws and other legal requirements, right? Well, the fun doesn't have to end there. We can use tools like AWS Lambda, which I talked about before, or if you're used to a more sort of Docker world, we can use tools like ECS, which is like, well, it's serverless because you don't think about the server, but you still pay for every minute that it's running, right? So we can use these to build APIs in any language, any tool, and upload it to AWS. You can do this stuff with Azure and Google as well, just focusing on AWS because that's what I use. I'm going to be honest, can't remember if this works with EC2. I'm sure it will do because you can interact with an API gateway, but I just haven't used EC2 for so long, I've completely forgotten how it works. So look, we build an API in any language and we upload it to these two. We can then connect it to AWS's API gateway, and we can optimize certain endpoints to work using edge compute, right? We can be like, well, distribute these endpoints across the edge and these others not, right? So we can still take advantage of edge even when building APIs in sort of traditional ways. And there's one worthy mention here that literally came out like 5 days. I think it was at the beginning of the week. So I was sat up north. I'm going to butcher the name, so I'm really sorry. But in Granga, the place where the cruise ships goes and all the beautiful mountains and the fjords, absolutely beautiful, by the way. Only reason I agreed to this talk was so I could come to Norway. So I was sat there reading, and Cloudflare have just dropped this new service called Smart Placements, right? So you can write Cloudflare workers, you can write a whole API, whatever, in Cloudflare workers, and they will choose what's the best compute type based on where your data is and all this other stuff for you, right? So you don't actually have to think about it, because their whole motto is, hey, look, we'll manage your servers for you, but now we'll manage your placements for you too. You just focus on business logic, which for smaller projects and certain things is absolutely brilliant, right? So we're getting to this sort of layer of abstraction where they'll pick the best compute and runtime for you. So what are my key takeaways? Look, if you're building a web app, you need to make it ready for the edge. You can do so much with full stack web applications. Vercel, Netlify make it super easy. SvelteKit, Next.js, other web frameworks, they're really taking advantage of this. You can do some really cool stuff. I recommend checking Cloudflare Workers and Vercel for their examples, because they have a whole host of examples of stuff you can do in edge functions. Think very carefully about where your data is located. Really, really, really think about it, unless you're using a tool that does it for you, because you will run into issues. Distributed data is normally extremely difficult to deal with. And sure, a lot of these new tools do make it easier for you and abstract that away, but really, really think about it. Obviously, edge computing is not a one-size-fits-all. It's just another tool in your belt. So, it's not the best thing for everything, but it is really incredible. If you're building an API only, maybe don't start on the edge. Kind of think about what you're doing, right? Like, if I was to go back in time and rebuild the API in Climate Clever, I might actually build it on Deno deploy and use Deno KV, because a lot of the data was also location sensitive, right? It changed based on where you were requesting it from. It didn't need a central repository. So have a think about what the requirements are. Yep, so that's the end of my talk. I try to keep it short in case there were questions that I may or may not be able to answer. You can find me on Twitter or my website where I blog about stuff. There are 2 blogs that kind of go along with this talk if you want to get access to information. Yep, that's it. Thanks very much. Yep, so any questions, let me know. If not, it's all good.
I know people have been talking about running a SQLite at the edge. Is that something you've kind of looked at? Or?
So there's so many new databases popping up at the moment. I'm sure there's going to be an optimized version. But for me, I've only been looking at sort of MongoDB, the key value stores, and PlanetScale. PlanetScale, yeah. But that's only because their marketing has just been shoved down my throat so hard, right? It's really hard to avoid. But if PlanetScale can do it for MySQL, I don't see why it can't be done for SQLite. That probably didn't help you at all. It's
No, it's okay. I just wanted to be new.
No.
I only vaguely know, so I just...
Yeah, well, it's changing every week. Yeah.
I think because it's so lightweight and tiny.
Yeah.
Talking about being actually up before, basically, the edge, and then people are looking at distributed SQLite.
Yeah, well, so some people are also looking at running long-standing compute services on the edge as well now, which is because for me it's all about serverless functions, but now people are here's constant running compute as well. So I think it will change, because I think the way PlanetScale works is it's not actually all distributed in, held in one place. It's kind of distributed as well based on where your requests come from, and they sort of optimize it like that. Yeah.
We ship a lot of, so I work for Just Eat Takeaway, so
yeah.
menu won't go over where you are.
Yeah.
And one of the things we do to reduce, basically, obviously to improve performance, is we try and put things like the menus the customers are using. They're just basically stored in an S3 bucket and then pushed out to a CDN, which is close to you, right?
Yeah.
And one of the things I was thinking about is whether or not, if you can run, because there's this whole thing about being able to run things like SQLite at the edge, where you could effectively say, well, rather than having just this JSON blob, which we push to the edge and then you basically download on your device or to basically the website,
Yeah.
you could actually just load it into something like a SQLite data store, and then effectively you get whole loads of query options.
Well, I mean,
I don't know whether that's actually
but
a viable thing.
but if it's just JSON, right?
Yeah.
So like you could probably use some of these new like JavaScript key value databases, right, that are globally distributed instead of an S3 bucket, which would pull it off just as easily.
Yeah, maybe we should.
But I don't know what the rest of the tech stack is.
It's interesting. It's a whole lot of stuff to dive into.
Yeah, it's really
Just
confusing.
Models to what were, rather than having to force the client to go, is this amorphous blob of data?
Yeah.
Which we now need to take down and process as to whether they would process it via basically the edge compute.
Yeah.
Good questions.
But I mean, another thing you can also do is you could like render the whole menu in an edge function and cache it too, right? Like so the UI is there and then the UI just gets downloaded too. But
Yeah, that could be.
yeah, there's lots of different approaches.
Yeah, we have quite a lot of data to give you.
Yeah, I bet.
So a lot of this stuff, it seems like it's really the sweet spot for us to investigate, but I've only just really sort of started scratching the surface of it, so I thought it's quite a good talk for me because it's like signpost the stuff I should go and look at.
Well, for us, it's like I mean, I'm using Java now at Atlassian, which I've never used before, so that's been really interesting journey. But like, I always end up coming back to JavaScript, right? Not because it's necessarily the best language, but because you can just do so many things with it, right? So lots of side projects get done in JS because it's super easy. But this is where like a lot of the edge stuff is happening because they're like, hey, just whack out this stuff really quick and like maybe JavaScript isn't the most performant language, but that doesn't matter anymore because like we can run it on the edge and we can get these instant computes and all this other stuff. So yeah, like you could store it as just simple JS values in a key value edge database, planet scale, or render the UI. I think there was another question.
I was going to ask if you have any suggestions or frameworks that are more focused to APIs. So for instance, like a lot of people use Svelte or
Yeah.
and they're always bundled together with the
Yeah.
UI part.
Yep.
Especially what you said, like running APIs or even closer to the edge.
Yeah. Yeah. So actually, some people suggest just building your API layer in Next.js and then forgetting about the front end. Some people do that. For me, that feels really weird. But like Deno, for example, it works. They have quite a few frameworks you can build APIs with. I think Oak is quite a popular one off the top of my head. They've all got weird names. I've built a simple sort of carbon emissions calculator using Oak and distributed across Deno and Deno deploy, and that's just an API layer, just returns JSON. But then, like I said, if you use AWS Lambda or Cloudflare Workers, you can use some frameworks like Express or is it Fastify? Yeah, you can use those. But the thing is, a lot of serverless compute actually kind of pushes you towards not using necessarily a framework and more just using the raw things that they give you. It's more about the stuff that goes underneath. Because it's like, hey, it's not a framework. Here, build an endpoint for sort of each thing and just think about that stuff. So the architecture is completely different. And I kind of hit the wall a lot because I was like trying to apply the same old school architecture that I was used to. Yeah. So yeah, so there's a what's it called? There's a framework called, I think it's an open source framework called, I think it's literally just called Serverless, which allows you to like build stuff using serverless functions on Lambda and things like that, and just deploy it. And then you can obviously use the config in AWS Lambda to choose edge locations for certain endpoints. I guess the thing is, my stance on sort of vendor or framework lock-in is very much that it doesn't really matter, like, because, I mean, we all try and avoid it, right? Like, hey, like, vendor lock-in is bad, so I'm going to add all these extra steps so I can just move from here to here. But, like, how many times do we actually really do that, Like, or how many times does a well-loved tool actually end? And we've just got, so, just use a framework that's already used. And then if it does suddenly die one day, then that's just part of your job to move it, right? Like, so, yeah, I don't know. Like, for me, I'd just use something like the serverless framework or Deno and Oak and just go from there. Yeah, cool. Any others, or are we all good? Nope. Cool. Well, thanks for coming, guys. I hope you enjoyed it.